Hello, friends. I am Sarajit, and I'm today starting an 8-part series on Industry 4 Smart Factory Systems. Just like the magical smoke you see across the screen, smart factories today are really magical in the way they create products and the way these products and services serve humanity. I am a business facilitator with 55 years of experience, 34 years in industry, including very large Indian companies like Escorts Limited and Mahindra and Mahindra Limited. The last 21 years, I have been working as a project-based consultant and into teaching at college levels and as a startup advisor. My mission in life is to share knowledge and add value to everyone I meet and to everything I do. This presentation today is about the journey from Industry 1 to Industry 4. It is a core module that I'm presenting, explaining how it all began. Our learning today will be about what are the 4 industrial revolutions, and we will be able to explain after this presentation the difference between the 4 industrial revolutions, one from another, and the progress that they made from Industry 1 to 2 to 3 to 4. Industrial revolutions were first described by Eric Hobsbawm, who was a British historian, and he coined the term Industry 1. And he gave the date of the start of Industry 1 as 1784, when first mechanization with power and steam was brought into the world. Before this, we had cottage industries only, and only muscle power and animal power was being used. In Industry 1, we started using mechanization using water and steam power. Really, Industry 1 began with the invention of the mechanized power loom, which was designed and created by Edmund Cartwright in 1784. He never earned much from this invention because he designed, created, and released this product to the world without having patented it. Then the second great phase of Industry 1 began with the introduction of steam locomotives. George Stephenson produced the first steam locomotive on rails called Rocket. This was built in 1829. His son, Robert Stephenson, one of the early true FRS that we produced, was a great designer of railroad systems, including steam engines. This is the steam engine that Robert Stephenson made. For more than 100 years, this design of a steam engine stood its ground, and whatever goes into the steam engine was used till 1970. Just imagine how great an engineer Robert Stephenson was. Then we come to Industry 2. The start of this Industry 2 era is 1913, when mass production assembly line using electric power came into being. It is electric power which gave rise to Industry 2.0. And really, what distinguished this from the early Industry 1 was the division of work, a moving assembly line which produced mass production products. And all this was possible because of the invention and uh, other capabilities which went into producing interchangeable parts. Henry Ford started this industrial revolution too with the production of his Ford Model T. He had actually built from scratch, totally designed himself, Model T, and it first started production in 1908, before Industry 2 came into being. Now, after this, when he produced his moving line, assembly line at Highland Park, we got into Industry 2. Model T was manufactured at Highland Park, a very big facility, in 1913, the first car being rolled out on October 7. Here is this moving assembly line shown. The products on this assembly line were put on this assembly line, and the assembly line moved due to electric power. Earlier, before the use of the assembly line, Model T before 1913 was produced in 728 minutes. Production time using moving assembly line ultimately got reduced to 93 minutes. See the difference. All this was possible because of use of a large amount of specialized labor at each workstation and the use of interchangeable parts. This also gave progressive price reduction of Model T. Before the assembly line came in 1909, Ford Model T was costing $950. And after the assembly line was introduced and stabilized in 1916, the cost of each Model T reduced to $360. And in 1926, this had come down right up to $290. During its production run, 16,500,000 Model Ts were produced. A great run for a great car that built America. This is how Industry 2 works. At each workstation, for a short time, the car stops and some work is done. Here we see the car being painted as it stops at a workstation. Another jewel of Industry 2 was the invention of the Toyota production system. This was created in Japan during the period 1948 and 1975. Toyota production system, known commonly as TPS, is the real bone behind the current modern production. It has two pillars, Jidoka and just-in-time. We'll explain what these are. Sakaichi Toyoda was the inventor and developer of two concepts of world-class manufacturing, which is another name for Toyota production system. He developed the 5 why concept of, getting to the root cause of any problem and solving it. And then he invented Jidoka, which is automation. The process of Jidoka in the Toyota production system has 4 steps. First, detect the abnormality, stop the work when this abnormality occurs, fix the immediate issue, investigate root cause, and do countermeasures so that this defect does not occur again. The emphasis on never letting the same defect occur again, which is continuous improvement. The real architect behind Toyota production system, who took this further on, was Sekiji Toyoda's son, Kiichiro Toyoda. In 1933, Kiichiro Toyoda established an auto division within Toyota Loom Works, and in 1937, Toyota Motor Corporation was formed. Kiichiro Toyoda developed the use of just-in-time for making vehicles. He got the idea from the department stores in America, which stocked their shelves just in time. And this is where the idea of just-in-time came, from another industry. And the final person who really developed TPS from 1948 to 1975 was Taiichi Ohno. He was an engineer in Toyota Loom Works and textile engineer. And when he was transferred to Toyota Motor Corporation, he made it really what it has become and is today. What he did was he integrated TPS into a social technical system. He developed the concept of using 7 ways and eliminating these ways wherever he found them. Today we have 8 ways. The 8th ways is the underutilization of people. And most important, Taiichi Ohno developed Kanban to achieve just-in-time. Kanban is a system of supplying products just in time. And in fact, to supply products just in time, you also make products just in time in the Kanban system. Industry 3 actually started in 1969. It is possible only because of computers fitted with PLCs and IT automation. This is what brought in Industry 3 in 1969. These PLCs and IT automation really automated production, and IT actually ran the whole network. This is how PLC really works. For those of us who are not familiar with PLC as a term, PLC really means programmable logical controller. This is a device which is fitted and into machines and computers to make the production of individual machines automated. You program each product one at a time, and it produces exactly what you have programmed into it. It does not have any way to improve things on its own. That came after we got into Industry 4. But it was a major step forward from Industry 2. This is how an individual machine with a PLC, which has been programmed by the operator whom you see on the left, really works. It keeps producing one after other as many parts as you want. These parts are exactly alike and are made to exact specification as built into the PLC and its sensors and controllers. Industry 4 began in 2015 after a lot of improvements in internet technologies. This system is actually central to cyber physical systems. Cyber physical systems run Industry 4 factories. Without cyber physical systems, there would be no smart factories. What CPS does is that it creates intelligent, flexible, and distributed production of components, machines, whatever it is producing, and services. Now, in Industry 4, we have different autonomous machines which are in contact with each other and with the humans working in the factory through Wi-Fi. Each machine knows what's happening within the smart factories and what's happening outside the smart factories. First, in the back end, the supply chain, right from where the material is mined to how it is progressively produced and brought into the factory. It knows all about it. All machines are aware of this, and everybody working in the system is aware of this. And then what product and services are produced and how they are being used in the market by humans and in industries where these products are at work. This is fed back to the smart factory. Now, how does the smart factory gain from this? We'll see this later on. Now, first, let us compare Industry 3 with Industry 4. At the field level, which we call real-time critical level, in Industry 3, we have smart assets in the form of individual machines which are run by PLCs and IT. In Industry 4, we have smart assets which are totally independent autonomous robots which do everything in the plant and are in connection with every other smart robo and automated system. So you see everything connected in Industry 4. Everybody and everything knows what's happening in the universe of the smart factory, Industry 4. Now in Industry 3, we have a hierarchy. We have real-time critical production of parts. And when we improve in Industry 3, what we really do is that, we introduce process controls and plant management control, and then enterprise resource planning level. So Industry 4 is totally going to replace Industry 3. There's no doubt about it. And Industry 3 ultimately will have no say in what really gets produced and supplied, because we are now coming into the era of smart products and services which can only be made in Industry 4 factories and not in Industry 3 factories. So in Industry 4, what is it that makes a difference? It is CPS, Cyber Physical Systems. As you saw at the top, we said the cyber physical systems changed the rules of the game and we got into Industry 4. What is the cyber physical system? This stores all information as a digital model. So what it does is that there is a physical production facility, and whatever is happening in the physical production facility is being converted into a digital model to show that, okay, before production started, this was how the model was being produced. The products and services that they produce, I call them model. So whatever physical production facility is doing, this is converted into a digital model. And then this digital model is compared with what's happening in the outside world, in the back end of the supply chain and forward in the customer end and the products that are being made. And everything is continuously improved, cycle to cycle. And the customer gets a totally customized product. So it is like mass production of one without any increase in cost. So what is the information which is stored in this cyber physical system? We have software, automation, safety, all the mechanicals, electrical, security, electronics, interfaces, maintenance, location, and everything here is actually run in the cloud. In the factory itself, for direct control, we have local computers and systems working. But they are fed information from the back end and from the customer end through the cloud. And whatever they're doing also goes to the cloud. The idea of using the cloud is to reduce as much as possible the lag between availability and use of information. That can happen only when things are handled in the cloud. So here, as I said, digital model holds up-to-date information, instantly updated information for the entire life cycle of the products and the services that are produced. As you see here, a smart factory has very, very few people. You see so many machines, they are doing what they're doing. We need not know what they're doing, but the people working on this, say the manager and the person who's monitoring things, on their screen, they can see what's happening behind amongst the machine when they're talking what they're doing. And where some changes are required, they can control these changes. But by and large, the machines learn on their own and produce things on their own. How often interference is required by humans depends on how well the machines are produced. If the machines are totally innovatively and creatively designed and fed information the way it should be fed, very, very little human control will be required. And as I said, they learn from doing, and soon they will surpass human intelligence. Thank you, everybody. Now, this is the end of my presentation. Please subscribe and also make comments to let me know what you feel about this presentation.